Hello and welcome. I'm Bill Wake. We're working on a basic interpreter. We've spent a lot of time over the last few weeks doing expressions, but I think we've got those completed. Then we spent some time doing cleanup on the error handling inside the interpreter and inside the parser. I think I want to switch gears a little bit. We've still got some control structures, some statements we haven't dealt with yet, so I thought we'd tackle those, starting with good old for next. And, okay, I meant to reboot my computer because I've got some weird escape key not working kind of thing going on here. All right. Okay, for next. Well, I went to the documentation. Always good. Here's the original. This is the basic paper from 1964 or 5. And they tell you a line number for variable equals expression to expression, or same thing with step expression. So we'd say step expression's optional in the end, and followed by a next statement that has the variable. And inside there is the body of the loop. Now, one thing is, like, basic was before any notion, well, before much notion of structured programming. Excuse me. So it doesn't, this is not a syntactic pair. Okay. So, normally you think of a loop, the start and the end of the loop sort of being a bracket. Okay. Either it's in curly braces or end while or something to mark the end of the loop so that this is really where it ends. In BASIC, it's just another line number out there somewhere, and you could get to it through any crazy path with go-tos and everything else. And so it's there's some we'll have to do some craziness to implement this well. We'll have to make our own little stack, I think. Okay, so omitting the step is the same as step size unity 1. I don't know why they didn't say 1. Okay, so the example, assuming a is 0, perform several times with x4 equals 6, 6.25, and so on. Okay. Apparently, cos of 0 is 1, plus 17 is 18, divided by 3 is 6, to 3 times square root of 10 is 3 point something. Okay. Last time the body will be x equals to 9.25, which is less than 9.486. Oh, I could have wished for an easier example. Okay, the for statement goes in the body of the loop if the variable has a value less than or equal to the final value, or greater than or equal to the negative value. Less than or equal to the final if it's positive step size, greater than or equal if it's negative step size. On leaving the loop, the program continues excuse me, with the statement following the next. The variable used in the for statement then has the value during the last pass through the loop. I may have to take a break early here. Okay. Here's some examples. This loop for x equals 8 to 3, step minus 1, 8, 7, 6, 5, 4, 3. Makes sense. X has value 3. Okay. I don't know why we would want to care. And actually, that's kind of complicates things, doesn't it? But okay. Minus 3 to 12, step 2, minus 3, 1 up to 11. Okay, good. This one's the one that gets me. For z equals 2 to minus 2. Okay, the body of the loop will not be performed because 2 is already greater than or equal to minus 2, and step size is implicitly 1. Instead, the computer will proceed to the next statement immediately following the corresponding next. The value of z will then be 1, which is the initial value minus the step size. Now, everybody else, I don't know, it just seems odd to me. Maybe it'll work out. We'll have to figure out how this loop works. All right. Now let's go over here. This is the OSI basic, I don't know, 1982-ish, maybe a little earlier. For loop. Okay. Step is only needed if not incremented by 1. Okay. Next X is needed only if 4 loops are nested, comma, semicolon. If not, next alone can be used. Period, capital V. Variables and functions can be used in for statements. Okay. Yeah, not great writing, I guess. or editing or something. I think the thing there is though that they're saying you could just say next instead of next X. They didn't give us that option up here. Let's see. I don't know. We didn't find the next statement, did we? For and next. Well, they don't say anything about the variable being optional, and you actually kind of need it in some sense. But okay, and then let's go see Commodore 64 or 1984-ish. All right, same syntax. The variable, okay, steps -1. Value in variables compared to limit. If limit's not reached yet, it goes to the line after the original for statement. Okay. Eventually the value is exceeded. At that time the loop is concluded and it continues with the line following the next. The value reaches 11, which exceeds 10, and the program goes on with line 130. To me, that implies that the value is still 11, not the final value, which is what this one implied. Okay. And note, a loop always executes at least once. Okay, that's directly contradicting this. The body of the loop will not be performed. Okay, so we've got some decisions to make, and oh boy, I don't even know. All right, so and the other thing is, in a for next, I mean, it's a sort of a compound structure, right? In the sense that I could write this with gotos and ifs and variables, normal variables, and it would be nice in some sense if I defined it that way, but that's definitely not what they did. So let's see. I got to work something out. Okay, where's my to-dos? All right. Let's work out some semantics. Okay. Well, let's put the grammar in first. That's the easy part, so we can do that. Okay. Statement goes to or expression. Okay, that's a little different. Okay. All right. So statement goes to for variable equals expression to expression optional step expression, and statement goes to next, and then variable, and we might make it or optional variable. Okay, if we want to conform to 1964, we require the variable. If we want to conform to this one, we don't. And I don't know, let's see if next is listed separately here. Next, okay. Oh, they get even fancier. Oh my gosh. This one allows multiple variables. And next can stop several nested loops. To do this, each name appears in the order innermost first. Okay. When using a single next, each variable must be separated by a comma. It can be nested to 9 levels. If counter is omitted, the counter with a current loop is incremented. Okay, so Commodore 64 allows us to omit variables as well. That's OSI, or variable comma variable repeat variable, and that's C64. Okay, so we'll start easy, and maybe we'll go up this far. I don't know if I want to mess with this one. Let's take this back a couple characters, get a little more space there. Okay. All right. So semantics of this thing, I'm just going to put this here for a moment for loop semantics. Okay. So for x equals expression 1 to expression 2, step expression 3. We know this defaults to 1. Okay. And next x. Okay, we'll start there. I guess I could put body in here. Although it's kind of not really true that it works that way. Because my first line could be go to somewhere, go to line 400, do some stuff, somehow meander back to 201, All right. So if I had to say what that's doing, well, I think it's the same as saying, let's put a label here, loop top. Well, just top x equals E1. Now, there's ambiguity here. Okay, so in semantics, right? Is this value fixed at the start of the loop, or can you vary it as you go through? I don't think they've said. I believe it's fixed. Okay, so let's assume it's fixed. All right, so I guess we could say, I'm making up names that I can't support, but limit equals E2, step equals E3. Okay, I guess I'm saying I got to evaluate those things. And then wow. Let's take the simple case. If step is greater than 0 and I think x less than or equal to limit, then we do something. Wow, this is really a mess semantically. Okay, if I think the implication is you're not going to have. Well, how's it going to find the end of the loop to go there? Right? Given all the messiness. I don't know. Wow, this is probably why they executed it at least once in Commodore 64 land. It's just, how do you know where this next is when you haven't seen it yet? Okay, and so I think, okay, I don't know. I'm going to make up something. Let's do a variable execute equals true. Okay, and then I don't know. That doesn't sound so good either. My idea was I would not execute anything until I got to a next statement. But I would have to execute go-tos. Okay, unless there's a limitation that says there's only one version of this. I mean, this is why they require the variable, probably. Wow. I may want to do more research on this. I don't know. Is it boring to watch me do research? More boring than watching me type? All right. Well, what I'd want to do, if x is equal to limit, I want to reverse this. Okay. If let's just focus on positive for now. Okay. If x is less than or equal to limit, then we want to do the body. And then I'll say end if, because I'm not writing basic here. I'm writing some pseudo language, or I guess. Okay. So I'm only going to execute the body if x is less than or equal to limit. Then I guess I need to do my increment inside there. And then down here, I guess I've got the bottom is after that. So if x, let's do it this way. If x is greater than the limit, go to bottom. Maybe top is in the wrong place. And then here, go to top. Is that right? Okay. If x is, we start off x. If it's less than or equal to limit, we want to do the body and then increment and then go back to the top. Okay. And we've used the limit, we've used the step. If it's greater than the limit, go to the bottom, and this is where the next statement comes in. Okay. Now maybe who does what? Maybe the next statement should be doing this stuff. Okay, so if this is all generated by the 4, and then this is generated by the next. Okay. All right. These seem okay to me. I mean, so I'm saying I evaluate these before, so I don't change E2, E3, the limit or the step, during the execution. The problem is when I'm at the for statement, I don't know where bottom is. It's hard to know who can do stuff. Well, okay, I guess the thing is, if I treat it as, I mean, this is the interpreter. Body is itself. Okay. So I have to execute something at the start, and I execute this line. How do I know where bottom is until I see the next statement? That's the puzzle. Now, there's another, I don't know, thinking like a tricky compiler person, right? It's like I could put stuff here, like I could say, go to start, where start is this. Well, this is repeat, okay, and this is start, okay. the trick would be put the increment up here. Okay. So the loop then would go to repeat. How would that work? I don't know. I mean, so you can see it's kind of bouncing around a little, but we would skip over we could define the increment up here because we have all the information, and then skip over it for the first time because we're just going to start by checking the loop versus the limit. But go to bottom. Yeah, I don't know. This is definitely a challenge for this. And okay, so and I can see the Commodore 64 one that says, "Oh, the loop gets executed once." It probably puts the test down here with the next statement, and so it's kind of like a repeat until more than a while loop, if I can say it that way. So let's try and define that one. Um, okay, so we still have it. We still have these three lines. Okay, if we did it as a repeat until, we would do the body. Well, body. Okay, and then somewhere up here we got a repeat label. Okay, generated by the 4, and then down here, the next would say if probably x equals x plus step, if x is less than or equal to limit. Oh no, was it just be less than, right? If it's equal to limit, we already did it, so it's less than. Go to repeat. And then the following, the rest. Okay. That's doable. So we would track we'd track the variable x. We'd keep track of these two in some sort of, actually these three things. Where's the repeat go to, and like where do you jump to, and the limit and step size in some sort of, that's going to be what's in the stack I talked about, because they said you must nest them even though it's dynamic. They are nested, but yeah, it all comes down to, I don't know where the next is. Let's go back to the top. I don't know where the next is when I'm interpreting this. So that definitely makes the complications. And I don't have a good way to scan for it because the body could be all kinds of crazy ifs and jumps and like that. All right. And in the OSI one where I don't have to have the variable, right? I'm dynamically saying, okay, you take your last loop and do the stuff. You use the last loop. So I can't even, if they were all next all over the place, I don't even know which one corresponds to X. I suspect that's why it's required in the original BASIC, and I also suspect maybe they only let you use it once. I don't know if that's the case. It may be they did a text scan go forward Again, this kind of wouldn't surprise me if it was like go forward until you find the next until you find next X, and as long as you don't nest X inside, an X loop inside an X loop, I think you'd be okay. The weird thing is, I mean, I think I could write code like this. Um, if loop end, let's make a variable loop end. How about if loop not started, if not loop started, then jump to 100. 100 is for x equals 1 to 10. And then line 90 is next x, and line 95 is go to 200. Okay. And then 110 is print x. And 120 is go to 90. Okay. Let's add another line in there. Sorry. 105. And this is loop started equals true. Okay, and in here loop started equals false. 50, 60. Oops. Does this work? No. Not at all. Okay. So, okay, this is me trying to think. Again, I try and think like a mindless machine here. If this were my code, loop started as false. Okay, not started yet. Okay, jump to 100. Loop started as true. Now I run my loop. And actually, I can make this go to 60. Okay. And so here's my next is textually preceding my for, because I jump back here and then do the next, and then at the end I jump down to 200, do more stuff. Okay. I don't, do we need to allow this? It's an amazingly complicated structure. I mean, the semantics of it, the parsing of it's going to be trivial. We've already got all the pieces together. Okay, so, wowzers. Is this legal? Like, what are we going to do? I guess if we make the restriction that it's the nearest following next with the same variable or not, I don't think it matters. Let's start with the same variable. The nearest following x with the same variable. Then we would scan forward. I guess our interpreter would it would scan forward, asking for following line, following line, following line, until it hit one that said next X. Okay. And if it doesn't, then it's like, we'll say like either no next statement found, or the next must follow the for in the text, or something like that. Yeah, that's surprising semantics to me. I didn't think it had to be this hard. And maybe, I mean, is there a way we can do this? So these approaches, this is number one, is okay. If the